My name is Ahmed, and in this particular section of our class, we are going to discuss how to make a cluster in Linux. So let's get started. Before we start creating the cluster and before we start configuring it, some of you might not be aware of this term cluster. What is a cluster and why you should use one? A cluster, in very simple words, is a way of providing highly available applications. A cluster typically consists of 2 or more machines running Linux or any sort of operating system that supports clustering, and each host contains a replica of an application or a service. So, for example, if we are having a web application that is hosted on a particular web server, we need to ensure that this web server or this web application, will never go down, or at least it's going to be 99.99999% up and running, which is the famous 5 nines percentage as it is sometimes called. So in order to achieve this, and because operating systems and machines tend to go down and tend to fail for various reasons, like for example a network failure, a disk failure, a human error, any other sort of failure might cause the web application to go down and will cause the company that is using it to lose money. So by using a cluster, there is more than one copy of this application scattered around 2 or more machines, and those machines will share a common IP address that is called the service IP, or it's sometimes called virtual IP or VIP for short. Any traffic received by this IP address is routed to one or more of the backend machines depending on the architecture. If you dig deeper into this topic, you will find that clustering has several models. You have, for example, the active-active and the active-passive. In the active-active, you have both nodes or all the nodes in the cluster all serving the application at the same time. So if one of them is down, the application is not affected because the other nodes are still serving the same application. If you are running the active-passive model of the cluster, then one node is serving the application, the other one is in standby mode. If the first machine runs into a failure for any reason, the cluster will detect that this node is out of service, it can no longer serve the application, so a process that is called failover is going to happen, where the resources, and by resources I mean all the components of the application, are moved to the standby machine. The standby machine becomes active and it starts serving the application. So what are the resources that the application might use? In our example, if we have a web application, then it will use first an IP address. We have already discussed this. It's going to be a shared one. It is also going to use a shared storage. And by shared storage, I mean a disk or a group of disks that can be moved from this machine to the other one dynamically. We're going to see this in more detail in the lab. Just understand for now that the resources that are typically used by a cluster are the IP address and the disk storage. So by using a cluster, you ensure that the service is always up and running, because if one machine is down, the other machines will continue to provide the service. So in our lab, we are going to create a 2-node Linux cluster. Both of them are going to be running CentOS 7, and they are going to be hosting a very, very simple web application. I will be using VirtualBox for this demonstration. So let's have a look at what I'm exactly going to do in this lab. So this is VirtualBox, and this is the machine that we have created earlier in this class, CentOS. I've just renamed it to CentOS 1, and I also created a clone of this machine, and I called it CentOS 2. If you want to clone a machine, all what you have to do is right-click. If you are in VirtualBox, just right-click on the machine and choose Clone. You will be presented with this wizard. You're going to choose the name of the machine. In my case, I chose CentOS 2. And don't forget to click on this checkbox here, reinitialize the MAC address of all network cards, in order to ensure that the network card that the new machine is going to get will have a different MAC address than the source. Then you are going to continue cloning the machine. After the cloning is done, you will have a brand new machine that is an exact replica of the first one. I called it here CentOS 2. So let's start both machines. I'm going to show you the IP addresses that I have given to both of them. So have a look here. This is the first machine. Let's open terminal. Okay, this machine is going to have the IP address of 192.168.56 56.102 that is showing here. While a second machine, let's open a terminal here again. It's going to have the IP address of 192.168.56.103. And if you want to know how to change the IP address of the CentOS machine, there are several ways to do that. You can do it on the command line, or you can do it on the GUI. If you want to do it in the GUI, which is, I believe, easier, just click on this icon at just the one that is beside the clock on the right corner of the screen, and click on it. Just this one, and go to these are the Ethernet connections that I have. Just click on the appropriate one and go to wired settings, and you will be presented with this screen, which you can edit the connection by clicking on this gear at the bottom right of the screen, and then go to IP version 4. Here I have chosen to manually add the IP address of the machine because, of course, if you have a server, and especially if it was part of a cluster, it must have a manually assigned IP address. You cannot just depend on the DHCP to assign a dynamic address to you, which may or may not change in the future. You will have to use a manually assigned IP address, and this is exactly what we did here. So this is the first step of our lab, which is to create two machines and have CentOS installed on both of them. We already did that. Now the second step is that we need to have a shared storage. As we have just mentioned at the start of this class, at the start of this lecture, a shared storage is storage that can be moved from one node to the other. In order to do this, we are going to create a third machine running CentOS, and on this third machine, we are going to install the iSCSI target. If you are not familiar with iSCSI, it's just a way of accessing disks over the network using the iSCSI protocol. So I'm going to clone one of those machines. Let's just power off this one. I'm going to also power off this one as well. Okay, now I have both machines powered down. I can go to the first one, right click, clone, and here I'm gonna choose the name of my machine. I'll call it iSCSI, and of course I'm gonna click on reinitialize the MAC address of all network cards, continue, full clone, current machine state, just accept the defaults, and give it a few seconds to clone the machine to a new one. Okay, the cloning is complete. Now let's quickly have a look at the settings to see if anything needs to be changed. Okay, the storage. We want to add a second disk here because this disk is normally used for the operating system. If you want to share storage, it's a good idea to add a second disk in here. So let's just create a disk and let's make the disk, okay, 8 GB. That's nice. I'm gonna leave it at the defaults. Now I have two disks. The disk of the operating system, or the disk that is used to host the operating system, and a new virtual disk that I'm going to use as the shared storage or as the iSCSI target. Click OK and click on Start to start this virtual machine. It's gonna start with, of course, the settings cloned from the first machine, from the source machine CentOS1, so I'm gonna have to do some changes, most important of which, of course, is to change the IP address that it has, because it already has the IP address of CentOS1 machine 192.168.56.102. So once the machine is up and running, I'm going to use the same credentials that I used to log into CentOS1. It's just a clone of the first machine, so everything should be the same. Okay. Now let's go to Ethernet, wired settings, and okay, as you can see here, it's taking the original IP address. I'm going to have to change this. So let's go to this gear, IPv4, and I'm going to give this, let's give it an IP address that is recognizable a bit. So if the first one is 102, the second one is 103, let's make this one 10, for example. and I don't need a gateway here. This is an internal network, so all those machines can only reach each other through the internal network. They should not leave the internal network to the internet, so I do not need a gateway. Going to apply, and I'm going to refresh the network by turning it off, then turning it on again. So immediately the IP address of the machine changed to reflect the new setting. Okay. Now I have a new machine that is called iSCSI. Let's start back both machines, CentOS 1 and CentOS 2, so that I have 3 machines ready to run. Okay, so now I have 3 machines up and running. In the coming lecture, we are going to start configuring the iSCSI machine by configuring the disk that we created to be a target storage for both of the cluster hosts. So until next lecture, take care. Alright, welcome back. Here we are on our iSCSI machine. Let's go full screen mode. Okay. And the first thing we're going to do is that, as we have just mentioned in the previous lecture, that we need to convert this machine to an iSCSI target, or to create a shared storage that is going to be needed by both of the cluster host machines in this one, or in this machine. So first things first, the first thing we're going to do is we need to change the host name of the machine so as not to get confused. So let's go to Settings, Details of the system, and change this name from CentOS 1, because this is a clone as we mentioned, to iSCSI. Just like that. Now if I su to root, I'm gonna see that the machine name has changed to iSCSI. If I close the terminal and open it back, I'm gonna see that I have the name printed here, iSCSI. So the first thing we need to do after changing the name of the machine to reflect its role is that we are going to create a volume group for our shared storage, or for our iSCSI targets. So let's use the command line bg create. I'm gonna call this cluster underscore shared. This is the name of the volume group, and I'm gonna specify /dev/sdb as the disk that is going to be used inside this volume group. And of course, as you already know, Linux by default names its disks alphabetically. If it is connected using SATA or SATA, it names them alphabetically. So the first disk is SDA, the second disk is SDB. So since we have the first disk assigned or allocated for the operating system, we are going to use the second disk, which is /dev/sdb, so for our iSCSI target purposes. So we are going to create this volume group with SDB. And of course, we will need to use sudo for this operation because it requires root privileges. Okay. And now the volume group has been created. So the second thing we need to do after creating the volume group is to create a logical volume using the lvcreate command, lvcreate-l. And I'm going to create 2 disks actually, or 2 volumes if you wish to call them, 2 logical volumes. One will be for the shared storage itself, the storage that is going to hold our files or the application files. And this storage, as we mentioned, is going to be movable between those nodes. And I'm going to also create another disk that is called the quorum disk. The quorum disk in cluster terminology is just a way, or one of the ways, by which the hosts of a cluster determine whether or not the other hosts are healthy or are active. So let's create first our shared storage disk. I'm going to create it as 5 GB in size. I'm going to call it LV shared. And of course, I'm going to specify the volume group name as cluster underscore shared. Okay, so here I created the first disk. The second one, because it's just a dummy disk, it won't hold any data. I'm going to give it 1 GB of size. And I could have used something that is smaller than that. And I'm going to call it quorum disk. So QUORUM. And of course, it's also going to be part of the cluster shared volume group. Okay. Now we need to get the initiator name of both hosts, centos1 and centos2, because we will need to use those initiator names in order to give them the appropriate access to the LUNs that we are going to create. So in order to get the initiator names, I'm going to SSH to each node 192.168.56.101.102 for the first node. I'm gonna have to go to, of course using sudo, the file that holds the initiator name is at /etc/iSCSI/initiatorname.iSCSI. Okay, and because both machines are clones from each other, I will need to manually change this initiator name. The initiator name is nothing more than a unique identifier of the machine over the network in the iSCSI environment or in the iSCSI ecosystem. So I can change this, for example, to be node 1. I'm just gonna change the last part of the IQN to be node 1. I'm gonna have a copy of this one, or we can just cat the contents of this file so that we are able to use it later. Okay, this is the IQN of node 1. Let's exit. I'm gonna go to node 2. Enter the password. Okay, and again, I'm going to go /etc/iSCSI/initiatorname.iSCSI. Okay, and let's change this to be node 2. Now I have changed the initiator name of both machines. I will just have to take a copy of this initiator name because I'm going to need it when I start configuring my target. So, okay, now let's maximize the screen. I'm going to switch to root in order to not have to use sudo, because I'm going to write several commands that needs root access. And now we are going to use the target CLI command. Let's just ensure that it is installed. Target CLI. Okay, it is installed. If it is not, you'll just have to use yum-y install target CLI. The target CLI is the interactive prompt of the iSCSI that allows you to create the necessary targets on the system. So let's go to /backstore block. Remember, we are inside the iSCSI interactive prompt, so this is not the normal shell. And the commands that we are going to run here are specific to iSCSI shell or the iSCSI prompt. So I'm going to create the first file system of the first logical volume that I have created. It's going to be called Apache-fs for file system. It's going to be under /dev/cluster_shared, which is the name of the volume group, and then L shared. Press enter. This created the first storage object. Now let's create the quorum device or the fence storage device. Let's call it fence_storage /dev/cluster shared again and L quorum. Okay. So now I have my two storage objects created. Let's go to /iSCSI. Let's create. Okay, and this will create the target IQN. So let's get inside this IQN, inside TPG1 LUNs, and then type the following: create /backstore/block/Apache-fs. So this will create the first LUN. We're gonna do the same command but for the fencing device or the quorum device. Fence_storage. Okay. Now let's go to the ACLs or active control lists, and we are going to create the IQNs for both nodes as follows. Create. Now we need to have the IQN of each node. So let's open a new terminal here in order to get the iSCSI initiator name. I'm going to SSH to the first node. 102. Okay. Let's cat /etc/iSCSI/initiator name. Okay, and get this name. You can change it if you want to. This is a unique name over the network. You can change it to whatever name you like. Just be sure to be unique over the network. Let's paste this here. Click create. That will create LUNs 1 and 0, which is a storage device and the fencing device, and will give access to this IQN, to that node, to that storage. Now let's exit from this machine and go to the second one. Issue the same commands, cat /etc/iSCSI/initiator.iSCSI, and copy or highlight this string of text, copy, and again create and paste the IQN of node 2. Now we have created both IQNs for both of our nodes. Now the only thing that is left is to exit. But before we do so, let's save this configuration by typing save config and then exit. Okay. Having entered those commands on our iSCSI target machines, we have successfully created 2 disks. One will be for the shared storage of the cluster. This one is going to hold the application files and directories. The other one is a fencing device or a quorum device, and it is used to determine the state or the availability of the nodes of the cluster. That brings us to the end of this lecture. In the coming lecture, we are going to start configuring our cluster nodes. So until then, take care.